morning, everybody. Good morning. It is great to be here, and I want to thank Will for this conference and for Deloitte and Caterpillar and GE and all the great sponsors. I mean, we've been thinking about doing this event for the last 3 years, and finally got convergence to make it happen. You know, we have 3 incredible conferences, Exponential Medicine, how all these technologies are transforming medicine. We're doing it in finance, which will get massively disrupted, changed, reinvented. And the third place that we were absolutely just felt compelled to bring this together was in manufacturing. And as you're going through these next 2 days, what I'd like you to think about is consider this event as it grows, and this is, just stage 1. Consider this event the place that you come to get a sense of what is going from deceptive to disruptive in the manufacturing field right now. So let me jump in. I'll come back to that theme in a little bit. And my goal here is to provide some foundational information upon which an amazing slate of SU faculty will be adding. So I want to give you a sense of why now is different. Why is this decade, the next decade, not interesting times, the most extraordinary times ever in human history, and they truly are. So I want to begin by having you understand a cognitive bias. And I know there are a number of you who are in the SU family, X Prize, Abundance 360, members of the people who I work with. So you've seen some of this content, and I wanted simply to be a reminder of of the mindset that you're stepping into these next 2 days with. So our brains, the wetware and hardware of our brains, physiologically, the way our brains are wired, the way we think, evolved in a very different time. They evolved hundreds of thousands and millions of years ago, back when the world was local and linear. And because of that, the way we think is local and linear. But today, we're living in a world that's global and exponential. Things aren't changing century to century or decade to decade. They are changing year to year, right? And things are not local. Something happens in China or India, you know about it seconds later, computers know about it microseconds later. And this is fundamentally different than ever before. And you'll see this curve 1,000 times in the next 2 days because it's really important. That red line is us. It's you. It's your board. It's our customers. It's our children. It's our families. As humans, we are and have been linear thinkers. We haven't been increasing our capabilities, our cognitive capabilities. But that yellow line is what we're here to talk about over these next 2 days. It's computers, networks, sensors, AI, robotics, 3D printing, synthetic biology. All of these technologies are doubling in power year after year. And the difference between these 2 lines is why you care, right? The difference is either going to be disruptive stress or disruptive opportunity. Because if you're the CEO of a company that's been doing it the same old way in manufacturing for the last 150 years, we're a proud family company, we've been doing it the same old way, guess what? It's going to be disruptive stress. If you're the CEO of a new 3D printing technology and a new material process, whatever it might be, it could be disruptive opportunity. So I opened my last book, Bold, with the story of Kodak, which in one sense was a process company that in 1996 was at the top of its game, a $28 billion corporation, 140,000 employees. And Kodak, most people don't know, 20 years earlier had invented the digital camera. They had invented it in their labs. A guy named Steven Sasson had put it together, and he walks into the boardroom of Kodak with this large, clunky device that takes 0.01 megapixel images in black and white recorded on a tape drive. And of course, the Kodak board says, "Are you kidding me? This is a toy for kids. We're Kodak. We make beautiful high-resolution images. And besides, we're in the paper and chemicals business." And they promptly ignored it. And in the same decade, in 2012, Kodak files for bankruptcy, put out of business by the very technology that they had invented. They had the first intellectual property patents for. They had the first mover advantage. But they forgot what business they were truly in. And so one of the questions during these exponential times is for you to continue to think about what business am I truly in? How am I serving my customers? Because the way you serve your customers, the plant facilities that you've invested millions or billions of dollars in may be obsoleted faster than ever before. And how do you remain agile? Agility is going to be one of the key takeaways you need to be thinking about. In the same year that Kodak goes bankrupt, 2012, another company, also in the digital imagery business, gets acquired by Facebook for $1 billion, Instagram. But they've got 13 employees. Now, I've given this moment in time where a linear thinking company gets displaced by exponential technology, a name I call it the new Kodak Moment. And I believe there are going to be a lot of new Kodak moments in the manufacturing world. How we build our houses, how we build our fittings, how we build our cars, how we build everything. And the same day that Twitter goes public, Blockbuster goes bankrupt. And the stat from the Olin School of Business that in the next 10 years, 40% of today's Fortune 500 companies will no longer exist, only backed up by this stat from Yale, which says if you started a company in the 1920s, the rate of change was rather slow. You had 67 years on the S&P 500 before you were disrupted. Today, you get on the S&P 500, you're on it for 15 years. It's MySpace disrupted by Facebook, disrupted by Snapchat, or whatever's next. And what we're also seeing, and this is the challenge, this is the excitement, is we're seeing young entrepreneurs going from I've got an idea to I run $1 billion company faster than ever before. Right? Chad Hurley starts YouTube on his credit cards and sells it to Google for $1.6 billion 18 months later. Uber, you could not have conceived of a couple of guys literally building a company, never buying a car, displacing half the taxi fleets, rental car company fleets, and being worth $67 billion inside of 5.5 years. So when we talk about exponentials, that is what's going on differently right now. And you saw this in Will's charts, but again, we don't intuit this. We don't think about this. We, as humans, I have 2 5-year-old boys, and right now, they're learning their basic maths. And it's, 1, 2, 3, 4, 5. I'm a linear thinker. In 5 steps, I'm 5 meters away. And 30 steps, I'm 30 meters away in the back of the room. But that's not the world that we're building. The world that we're building is an exponential, where the power of the technology is doubling. Might be every year, 18 months, 24 months, it doesn't matter. That doubling power leads to unexpected results. Because in 30 doublings, I'm 1 billion meters away. Put differently, I've gone around the planet 26 times. And that disconnect between I'm 30 meters in the back of the room or I've orbited planet Earth 26 times is what got Kodak in trouble and what's going to get any company that's not really surfing on top of the tsunami crushed by the tsunami. It's the reality of the world that we're living in today. So I'm very proud. We have an amazing group of companies that are backing Singularity University. Ray and I co-founded this because there was no place in the world that you could go and learn about all of these areas in a convergent way. I spent 10 years across the Charles River at MIT and at Harvard Med School getting the best degrees I could, a 6-pack of degrees to get me to become an astronaut. But at the end of the day, you become the world's expert in a very narrow niche, right? You're in particular material science, in a particular, plasmid genome, whatever it might be. But what we're trying to do here at SU is something very different. It's not about making you an expert in any one of these technologies. It's about consistently giving you an overview of where these technologies are today and where they're likely to go. I started by saying we can't think exponentially, and we can't. Our brains aren't wired that way. The best we can do is make short-term linear projections. And so what SU is about is creating a venue like this one for you to come back, hopefully every year, every 2 years, whatever you want, and get an update. This is the world today, and then a year from now, this is what's now possible, and then this is what's now possible, because that's the only way we can do serial approximations to the kinds of growth we're having. We run programs for graduate students. We have thousands of graduate students around the world. We run executive programs. We run programs with Deloitte and X Prize called IPP for Fortune 200 corporations. Now, all of this exponential growth, at least in the computational realm, is riding on top of what we call Moore's Law. And I want to just give you a sense physically and at a gut level what this is. So this is Gordon Moore. In 1958, Gordon Moore partnered with a few individuals and started Intel. In 1965, 7 years later, he writes this paper and he says, at Intel, we've noticed something. The number of transistors that are able to fit on an integrated circuit has approximately doubled every 12 to 18 months for the last 7 years. And it's likely to continue. And that statement that it's likely to continue has continued for 50 years. It's slowed down a little bit from 12 months to 18 months to 24 months, but it's been a constant force of nature. And take a look at what that looks like. So on this chart, on this graph over here, you see two bars, a horizontal bar and a vertical bar. This is the first two transistors connected. It's an integrated circuit, half-inch feature size. Fast forward to 1971, this is Intel's first commercial product, the Intel 4004. 2,300 transistors, about $1 each. Now, my mom used to say that the world is speeding up. And I was like, come on, Ma, that's ridiculous. But the fact of the matter is, this is what's made it speed up. Right? 40 years later, the 2012 NVIDIA graphical processor unit is now 7.1 billion transistors at a millionth of a penny each. So 100 billion-fold improvement, which is extraordinary. Right? But guess what? It doesn't stop here. It continues on beyond this. Let me give you another visual representation. In 1956, this was a hard drive. And if you had the ability to get your cargo airplane and move your hard drive from location to location, you were in good shape. 5 megabytes, $120,000. Now, we probably all noticed when this occurred, right? When in 2005, it's 128 megabytes for $99. But did we notice when it was all of a sudden 128 gigabytes for $99? 1,000-fold price improvement, right on schedule on Moore's Law. 30 million-fold price improvement. And guess what? Again, it doesn't stop here. Now, I'm advising companies that are working on 1 million-fold improvement in memory densities.